are you, my friends? This video is presenting 8 old exams questions related to complex numbers. Now, if you want to see, please, complex numbers, the lecture itself, you can go to Algebra course, lecture 23. You will find all the rules there. Here we will go only for the questions. Old exam question number 1, z equals minus 5 I to the power 61 plus 2 minus I2 plus I. We need to find z bar. Now we know z bar is the conjugate. So let's simplify the z first. 61 I to the power 61 divide by 4, 15. Take the remainder only. So the remainder is 1, so this is I only, minus 5I. Now this one here, there's a formula, 2 minus I2 plus I, the conjugates. You can see it in the lecture. It's a squared plus b squared. So 2 squared plus 1 squared is 5. So this is 5 minus 5I. That's z. Now the conjugate, we change the sign of the imaginary part. Let's multiply them. Also, we have to use this formula again, 2 times. 25 plus 25 is 50. Question number 2, z is equal this, and w is equal that. Find z plus w bar, the conjugate. Here multiply the conjugate of z, separate conjugate of w. Here conjugate of z plus z, and this is minus 3i cubed. So you have to simplify all this. I hope you can get the answer, 4 plus 5i. Let's see. Z plus w, I add them here. See, 2 minus 5i, 3 plus I, 5 minus 4i. The conjugate, 5 plus 4i. So we write it here, there. Now, z1 times z bar times w bar. This one bar becomes 2 plus 5i. We have to multiply by FOIL. Figure it out. It will be 11 plus 13i. Z bar plus z. Z bar is 2 plus 5i. You add the cancel here, you get 4. See, take all these 3 numbers here, put it there, and we know I cubed is minus I times minus 3. You will find out the answer, 4 plus 5i. Please try it. This one, we have I power 5, 4i minus 3, 4i plus 3, divided by this is equal k over d in simplest form. Find k times d. Now, are these conjugates here? This is a little trick here. Are these conjugates? Let's see. They are not conjugates, no. See, the conjugate a plus bi, a minus bi. So I leave this one, 4i plus 3, is the same as 3 plus 4i. The first one, I take a minus out, common factor, becomes 3 minus 4i. Now they are conjugates. See, I can use the formula, but remember there is a minus outside. And now I power 5, we know it's I. When you divide by 4, the remainder is 1. And there is a minus here. Square root of minus 400 is 20i. You see that one is 20i. Now what is the cube root? Down. See, there's a down here, minus 1. See the cube root here? Cube root I did not mention. Cube root of minus 1 down here is there, it's minus here, so you have a minus. This is only 20i. So now let's multiply. There is a minus I here by using the formula, 3 squared plus 4 squared, and there is minus 2i down. So this becomes 25, and there is a minus I over minus 20i. I and I will cancel, minus and minus will cancel, simplify, 5 over 4. So k is 5 and d is 4. Multiply, get 20. Now, same idea here, but you have to be careful about the powers. Cube root of 27, square root of minus 1, that's I. This one here, remember, square root of minus 3. Square root of 3i. Don't multiply here. Don't multiply unless they are the real numbers. You can go and check the lecture, please. This one, I squared, I cubed, I power 4. You have to be careful until you get a plus bi. So this one is 3. Square root of minus 1 is I. This one, there is an I, remember. Any negative number under the square root there is an I square root of 12. Now we can multiply this square root of 36, which is 6. But you have I squared, which is minus 6. If you write only 6, That's wrong. And this one here, I is I. See, I will leave it. Cannot do anything. I squared minus 1. I cubed minus I power 4 is 1. So when you add everything here, you get what? Minus 2 and 2 cancelled, minus 2i. See, minus 2i multiplied by the conjugate, which is 2i up and down here, conjugates of the denominator. And this 3i, I can write it minus 6 at the beginning, plus 3i, that's the same. You can leave it like this if you like. When you multiply, you get minus 3 over 2 minus 3i. So a is this real part, minus 3 over 2. B is the minus 3. Divide b over a. So this is b over a. A you can multiply by the reciprocal. So becomes 2 is the answer. B over a is 2. We can ask you for a, we can ask you for b. We can say a plus b, we can say a times b, we can say b over a. Same idea. Solve the equation, that's quadratic equation. We have done similar example in the lecture 23. See, here you can multiply by 2 to make the equation simple because we have a fraction, LCD is 2. Then you have to expand because we have to add 11x and 3x together until we get simple, easy, nice equation. So multiply by 2 first. See, this is 11 multiplied by 2, this is 6x. Now let's expand by using the formula here, x squared minus 2x plus 1. Multiply with the 2 because there is a 2 here. 2 minus 4 and 2. When you simplify the equation, you get, remember, the 2x squared, and this minus 4. So 11 is 7. Bring the minus 6 is 1 here, and that's a 2 there. So A is 2, B1, C2. Find the discriminant. The b squared minus 4ac, b squared minus 4ac. So 1 minus 16. Minus is negative, so we have discriminant negative. Solutions are complex. Just put the formula here, minus b, so minus 1, plus or minus 4, there is a 4 here, square root of minus 15, take the I out, and we cannot simplify square root of 15, leave it, that's the solution. Now, same idea here, z is equal this. I don't think this is easy question, but nice question. Z is equal 20 I to the power 1000 plus square root of minus 2 times square root of minus 50 over this is squared minus this one. See, here you have to be careful. Simplify the squared first. You know the formula, a plus b squared. A squared plus 2ab plus b squared, and then minus this one. When you finish all this, this is z. Make it standard. Then take z, multiply it by, this is what we need here, multiplied by z bar, the conjugate. Divide by the same z plus z bar. Now let's look at the solution of question number 6. We have here 20, I to the power 1000 divided by 4, and the remainder is 0. So this is I power 0, which is 1, you see here, 20 times 1. Here never multiply because these are complex numbers. See, this one you have to take I outside, square root of 2. This is square root of 50, take I outside. I and I is I squared. Now you can multiply square root of 2, square root of 50 is square root of 100. So there is a minus here, and square root of 100 is minus 10, and there is a 20, so that's 10. Down here you have to put the formula 3 plus I all squared, which is 9 plus 2ab, 6i plus I squared. When you put all these numbers down, you get 1 plus I. Now we need the conjugate here. Multiply by the conjugate at the denominator, 1 minus I. Leave the 10 outside, 1 minus I. Here you have to use STS, sum of 2 squares. You can check the lecture, please, 23 if you want to see the formula. 1 squared plus 1 squared, so that's 2. 10 divided by 2 is 5. So 5 minus 5i. What is this? Z, you see? Now, this is z, 5 minus 5i. Multiply by the conjugate, 5 plus 5i. Divided by z, 5 plus 5i. And the conjugate, see, this is the same because addition. You can put this one at the beginning, this one here, it's the same. So this is 10. So that's 5, the answer is 5 here. Now this one, it looks difficult. It looks difficult, I agree. Z is equal all this. A plus bi in the bracket a over a squared b squared. Find z plus z bar. So the only thing you have to do, simplify this until you get standard. Let's say standard, let's say 7 plus 10i. Then you find the conjugate. Then you add them. Now, believe it or not, when you simplify z, it will be 1. Believe it or not. See here, a plus bi, I leave it. Now I have the same denominator here. You see inside, a squared plus b squared. So I can put here a squared plus b squared. And then I can add a plus, there is a minus b. So a minus bi over a squared plus b squared. I can simplify the big bracket into this small big bracket. Now you multiply the numerator here because this is over 1. So that's the formula exactly STS. A plus bi, a minus bi becomes a squared plus b squared. All these cancel together. So z is 1. 1 plus 0i. The conjugate, 1 minus 0i. When you add z and z bar, it's 2. Really nice question. You will laugh. Now here we have z1, z2. Z1 is not simplified, Z2 is not simplified. Now, after you have to simplify first, Z1, Z2. Now find K if Z1 over Z2 is equal to this. You have to make an equation here to find this K. And there is also I to the power 94. So Z1 becomes simply 3 plus I, easy to do. Z2, this is a minus, see this is a minus. Cube root of minus 8 is minus 2, that's 2. Cube root of minus 1 is minus 1 here, and this is I. So 2 minus I. Now it's easy, see? Z1, 3 plus I, Z2, 2 minus I. This is the equation given. Oh, 94. Divide 94 by 4, the remainder is 2. So I to the power 94 becomes I squared. Now put Z1, 3 plus I over 2 minus I is equal this. Multiply here by the conjugate on the left. 2 plus I, 2 plus I, because you have to simplify the left side. You have to simplify the right side. Here there is conjugate. 3 and 3, 3 squared plus 1 squared. This is STS. Now on the other side, this becomes 5 cancelled. See, this is 5, 6 minus 1, 5, and 5i. Take 5 common factor, and there is a 5 here. See, that's cancelled. And now here we have 5ki plus 1. So this equation, 1 plus I, is equal 5ki plus 1. Cancel the 1, and then cancel the I. K will be 1 over 5. Not easy question, I agree. Please, you can go back and forth, try it. Expect this is a not nice question, but I think it's good as a bonus question maybe. All right, these are the answers. Now, if you need to see more examples, the formulas, STS, everything, simple equations, simple questions, go to the algebra course, lecture 23. It'll be about complex numbers. Thank you very much for watching. If you like the video, you can subscribe or share it with your friends. I hope I can see you in another video with another topic. Thank you very much and goodbye.